All right. Now you have seen some of the illustrations on how to apply the technical analysis using chi-square hypothesis for goodness of fit. All right. So now we're going to move on to the next functions of chi-square hypothesis test, which is independence between two variables. Right. Now, how these two variables are actually interrelated. We want to see whether these two variables are independence or dependence with relations to each other by using the help of contingency table, right? So let's stay tuned on this. All right, we're still on chi-square hypothesis testing. The second functions of using chi-square hypothesis testing is to check whether two variables are independent or are they related to each other. Right? So one way to do it is by using this contingency table. All right, this contingency table is called two-way classifications table, or sometimes you call that a cross tabulation, or I would like to call it just a simple table with rows and column. All right. Okay, so take for example, we can use this a very simple startup point here. You can see that most of the time we have the total enrollment at a university, and then we can sort of categorize them into genders. All right. So sometime for a certain education institute, you might be interested to find out now, does the gender itself, does the gender of the um, enrollment dependent or independence to their uh, sort of their job category, their study mode, their type of study, right? Whether they are enrolled as full-time students or whether they enroll as part-time students. Okay, so does gender um, have something to do with their types of study, or we can say that does the gender or is the gender independent um, to their types of study or mode of study, or um, is the gender dependent on their mode of study or the type of study in this case, right? So the main questions is highlighted here. Does the gender and the type of study independent independent, are they independent in relations to the university enrollment? All right. So in order to find this out, we will have to carry out the chi-square hypothesis test one more time. Right. Now the calculation or computations involved is pretty much the same as the previous example there. Right. Now the only difference is the information is captured in the form of data in this case. Right. Okay, now I'm going to show you some of the guideline we need to look at before we start to um, work out the technicality through a few examples. All right, the guideline. Okay, now as usual, for any chi-square hypothesis testing, we need to figure out its degree of freedom. But for the degree of freedom of test for independence is much more simple as compared to the test for goodness of fit. Right now, the formula is given by um, this multiplication. So the R stand for the row, how many rows we are having with respect to the contingency table that we are having, and then C is a column itself. The reason why we subtract 1 here is due to the restrictions for the row. So on each row there is a fixed total, so that is the restriction on the row, and then the subtraction on the 1 on the column is due to the restriction of the total on each column there. Now later on we will look at that restriction. Right? Now the formula to calculate the chi-square still remain the same, given as such. Right? Okay. So it's exactly the same. Now the remarks down here, we can read that through. Now the null hypothesis in a test of independence is always that the two attributes are not related. So we should mention that for null hypothesis, the first part is the null hypothesis. So the null hypothesis, this part, should always state that the two variables or the two attributes are independent. Then the alternative will be otherwise. Right? Now, the frequencies obtained from the performance of an experiment for the contingency table are called the observed frequency, exactly the same. The procedure to calculate the expected frequencies for the contingency table for a test of independence is different from that of the goodness of fit there. All right, now I'm going to show you how to actually calculate the expected value in the following example. All right, example number one. Right now, how are we going to calculate the expected frequency through this example here? Then you get an idea how to calculate the expected frequency, and then finally we can conclude the chi-square hypothesis testing. Right. Okay. Now this example one is related to violence and lack of discipline have become major problem in school in the US. Now, a random sample of 300 adults was selected, and these adults were asked if they favor giving more freedom to school teachers to punish students for violence and lack of discipline. Now, the two-way classifications table or the contingency table capture this survey. Right? So the result is as shown here. So in favor is F, against, and then those that have no opinion. Now we need to calculate the expected frequency for this table first, expected frequency from the table, assuming that the two attributes, gender and opinions, on the issue are independent. Okay, so we always assume that your opinions and your genders are independent. Okay, so therefore you will notice that the null hypothesis must state that the gender and the opinions are independent, whereby the alternative should state otherwise. Okay, all right. Okay, now before we move into the chi-square hypothesis testing, let's look at how do we calculate the expected frequency. So here I'm going to walk you through with the contingency table, right? All right. So here I have prepared the worksheet that capture the informations from the sample itself. Okay, you can see that just to check. Okay, hold on, I missed that out. Oops, my worksheet is gone. Okay, there you have it. All right. So from here we have just to check all the values are correctly entered. Now our first step is to make sure we get the total. Yeah, to tabulate the total first. The total vertically. So we're going to add up 93 with 87, so we get 180, and then we get the total, the row, each rows. So 93, 70, 12, we get the total here. For the second row, the total is here. For each column, we have to tabulate the total. So you can see that due to the restrictions of the total on each row and column, that's the reason why our degree of freedom is given by um, r minus 1 multiplied by c minus 1 here. Now, based on this, we have the three columns. We have two rows. Sorry, two rows. Yeah, correct. We have two rows. We have three columns. So therefore, our degree of freedom for this analysis would be a 2. Right. I hope that's clear. Let me reiterate the steps again. In order to calculate the expected frequency, first step, we need to tabulate all the total. So tabulate all the total for rows and columns. That's our first step. Okay. Now, once we have done that, Okay, we are going to calculate the expected frequency. Okay, how do we calculate the expected frequency for a man in favor? Okay, let's look at the man in favor. How do we calculate the expected frequency for men in favor? Very simple, right? So the formula is we're going to take the total of this. So because the method that I'm using is simple here, all you need to do is draw a line here and then draw a line here because we are interested to calculate the expected frequency for men that is in favor. So this column and this row here. So you can see that this line refer to this total. This vertical line refer to this total here. Therefore, the expected frequency is calculated based on 180, this one, multiplied by the total on the row and divided by the main total here. Alright, so that looks very similar like the resultant of these two factors. You can mentally use that um, assumption, right? Which is not accurate actually in this case. You can see that. Okay, so divided by the total here. So divided by 300. So therefore, you will be able to calculate, obtain the expected frequency for the man in favor. Right now, here I have tabulated this. So just let me show it to you. All right. So the first one, if you use your calculator, you should be able to obtain 105. Okay, 105. And then you are going to move on to the second one. The second one is calculated. Okay, take for instance this one, second one. Man who is against. Now the same thing, you're going to draw the column. You're going to draw that. So that will be 102 by 175 divided by 300. And then there you have it. You get the second expected frequency. And proceed on. And then if you total up all this, you should end up with 175. And then the same thing, if you total up this vertically, you should end up with 180. And then therefore, in total, you have 1, 2, 3, 4, 5, 6. 6 sets of um, expected frequency. You have 6 sets of, if you were to separate this contingency table, you should have 6 sets of observed frequency and 6 sets of um, expected frequency. Okay, so from here we are going to tabulate. We're going to tabulate the difference between all these value here. All right, so I'm going to show it to you here. All right, so I'm going to erase this. Okay. So that's the first questions there. How do we calculate the expected frequency? And then next, for the second questions, we are going to work out the chi-square value. All right, now I'm going to, because question 1 and question 2 are related. Okay, so I'm going to show the question 2. All right, second question is the continuations from question number 1 actually. The same sets of data. Here we have already calculated the expected frequency from the table. So we're going to carry out the uh, chi-square hypothesis testing for this example number 2 here. All right. So the questions here is, does the sample provide sufficient evidence to conclude that the two attributes, gender and opinions of adults, are dependent? So we're going to use 1% as our reference significant level, right? So as usual, we're going to start by writing our hypothesis statements. So here we will say that the gender and opinion are independent independent. They are independent, whereby our alternative would say that gender and opinion are dependent. All right. So I hope that is clear at this point. All right. So that's how it is. And then that is our objective here. And then we have already calculated the expected frequency, which are listed here. One expected frequency, two, three, 4, 5, 6 here. So we have 6 set. And then all we need to do now is proceed on to calculate the individual chi-square. So by taking the difference between these two here and these two, and so on. So we're going to calculate each one of these individual chi-square. 1, 2, 3, 4, 5, 6 there. And then we should be able to total up the chi-square value to be 8.253. So the observed, so from here I can conclude that the observed chi-square based on the sample that I've collected, or they have collected in this case, is 8.253. So that is the observed chi-square. And then we have already determined the degree of freedom just now. So we have 2 rows by 3 column. So we end up with we end up with 2 as the degree of freedom here, right? And then our significant level is 1%. Now we're going to pull out our MF19, and then to see whether our critical chi-square is greater than or smaller than the observed chi-square here. 1%, we should be looking at 99, so 99% under degree of freedom of 2. So degree of freedom of 2, 99%. So that will be our critical. Now, therefore, the critical chi-square is 9.210. So 9.210. So let's see how we should conclude that. Okay. So now let me get my graph on this, so it's easier to refer to. So you can see that degree of freedom is 2 now. Okay, so just let me change that, and then the level of significance is 1%, so that's 1% to be precise there. All right, and then you can see that the critical, so critical is somewhere here, so that is the critical chi-square. And then our observed chi-square is somewhere here. Our observed chi-square is outside of the rejection zone. So therefore, we can conclude that gender and opinions are independent. All right. So I hope that is clear. That is how we perform chi-square hypothesis testing to check for independence between 2 attributes or 2 variables in this case. Now, I hope that is clear. For the rest of the questions, all the working are exactly the same, right? So do go through that, and then yeah, we'll discuss this further. All right. So thank you very much for watching. See you again.